Okay, so today we're going to talk about areas of triangles, trapezoids, and rhombi. And again, I'm not about just looking at different formulas. I want you to understand what it means. So let's take a look at this. If I were to take these triangles and double them, wouldn't I have a square, or a rectangle, I'm sorry? So what is the area of this rectangle? Base times height, right? Well, don't we just have half of it? So the area of a triangle is half of the base times the height. Because in every single rectangle, there are two triangles that are exactly the same size. Yes. That's where the formula came from. Right? Does that make sense now? Where that came from? All right, so let's use that. This says find the area of quadrilateral ABCD if AC is 35. So here's AC. That's 35. BF is 18. And DE is 10. Well, don't I have two separate triangles here? Well, we're not going to look at those. Actually, we've got technically 1, 2, 3, 4 triangles here. But I'm just going to look at this triangle and this triangle. So let's find the area of the first triangle. The first triangle is half of 35 times what? 18. And my second triangle is half of 35 times 10, which gives me my total area of my quadrilateral. If you do the math, is 490 units what? Squared. Altogether. So let's look at these. So the same thing, I always thought the area of a trapezoid, the formula is so difficult, but not if you think about it conceptually, which you all love to do now that you have me, right? Isn't it two triangles? No, that's why we're going to average them. Watch this. How do I find the area of a triangle? Isn't it base times height, half of that, right? And don't I have two triangles here? So the first one would be that base 1, and the second one would be base 2 times height. Don't these have a common factor, or a couple of them actually? What do they have in common? They have a half, and what else? A height. When I pull out a half and a height, what do I have left? There's your formula. So it's basically like taking this base and this base and saying, well, if I add them up and divide by 2, and then multiply it by how high this figure is, I will get the total area. No, you don't need to do the top one. I'm just showing you where this came from. Because this is a hard formula to remember. But if you think about it conceptually, it's not hard at all. Right? It makes complete sense if you think about it conceptually. Thinking about the concept of it, what it means, not just memorizing a formula. Okay, so let's find the area of this trapezoid. So I need the base one. What is the base one? TS equals, we can count this, we don't need distance formula, right? 1, 2, 3, 4, 5, 6, 7, 8. And UR equals 1, 2, 3, 4, 5. What's the base? I'm sorry, no space. The height. 3. Is not all I need? So my area is half of 3 times 8 plus 5. Where'd I get what? I just plugged it into the formula. Half of the height.
I don't know, how do you know TS is the way and how is 5?
I counted.
Squares or?
Yes. See, James, 1, 2, 3, 4, 5. The top is 5 and the bottom is 1, 2, 3, 4, 5, 6, 7, 8.
Oh, okay.
And the height is 1, 2, 3. I just counted.
Okay. So you do half of 3, is that what you do?
Half of 3 is 1.5. 1.5 times 13 should get you 19.5.
Whoa. Did you find everything before you started?
Yes. Yeah, you have to find all the values to plug them into the formula, right? Nope. So the area of a rhombus is a little bit harder to see conceptually. It's basically, if I take, let's see if I can draw it quickly. It's taking the diagonal and the second diagonal and multiplying them by each other, right? Which would make a square, or a rectangle, sorry. But that is way bigger than this, so what do you think I'm going to do with it? Half it. So the formula is half of diagonal 1 times diagonal 2. But does it make sense conceptually? Yeah.
I swear, your favorite word is conceptual.
Okay. So let's use that. Oh, that's a good idea. All right, so we have to find 2 different things for this rhombus. Yeah, you said it. I need the distance formula. It's not that hard when you do it conceptually, right? All right, let's talk about it. Let's find this first diagonal, which would be NR. We have to find the distance of NR. So I am going to take the square root of, how far do I go to get from -1 to 4? I have to go over 5 units. What's the distance from my y's? -3 to 2. How far do you have to travel to go from -3 to 2? 5. Does everybody get that? -1. If you're at -1 on the x-axis, how far do you have to go to your right to get to 4? 5. It's the same thing. You just have to think about what it means. How far is it between my x's, and how far is it between my y's? So what is this? Isn't this 2 5 squared? Which equals 5 rad 2. Connor? Yes. Connor, if I want to go over to this point right here, let's walk there together. Got it, Jordan? Let's walk there together. How far do I have to walk to the right?
5. That's like 16.
That's 5.
I'm gonna cut it through.
Then, how far do I have to travel up?
5.
Oh.
I get that.
I know. Jordan asked too.
Oh.
Yeah.
So now we're going to do the other one, Jordan. Do this one with me. So I need to get from M to P. I need the distance from M to P. So I'm going to travel. How far do I have to travel over? 1, 2, 3. And down. 1, 2, 3. You see it?
Yeah.
Which is also our slope. 5 over 5 is our slope of one of them. 3 over 3 is our slope of the other one, right? See how it all comes together? Connor's making fun of me. How many 3 squares do I have in there? 2, 3 squared equals what?
3.
So we found both of our distances. So how do I apply this to the formula? Area equals half of 5 root 2 times 3 root 2, which makes what? Half of
15 square root 2.
15 square root 2 squared. Root 2 times root 2 makes root 2 squared.
So
Which would, hold on, which would be 15 times 2, which would be just 15. Unit, he says it's 4 and the square root of 4 is 2. You can look at it both ways.
Oh, I just can't. Okay, yeah.
Make sense? All right, here's our last example. If I have a rhombus RSTU, you're distracting me, RSTU, has an area of 64 square inches. So this time they're telling me what the area is, then telling me to find US if RT equals 8. There is one like this on the quiz. You will not have a picture. So how would I set this up? This time I know the area. It's 64. So it's half of what? Times what? No.
Times X. What your boy know what he's talking about? D2. D2. It's diagonal. D1. Oh my God. It's diagonal 2. US. Why can't you be extra guys?
It could be. It could be a smiley face if you really want it to be, right? It's a variable, exactly. So I know my formula for area is the area equals half of the diameters being multiplied by each other, right? So if I don't know one of the diameters, I just say, well, I don't know that one, but I know if you multiply it by 8 and then multiply it by a half, I'll get the area, correct? You don't have to, because 64 equals, what's half of 8?
2. Almost 4.
Now what do I do? Now I divide by 4? US equals 16. And we're done.
Okay.